Hello everyone, welcome to the Click Physics 1 course. In this lesson, we will discuss real images, virtual images, and mirrors. So let's get going. Real images and virtual images. Well, first of all, let's understand what an image is. An image is a shape similar to the object that is formed by the intersection of rays. When light comes from an object and interacts with a mirror or lens, the light rays change direction. Our eyes receive these rays, and our brain interprets where they come from, allowing us to see an image. And images can be one of two types, a real image and a virtual image. The main difference between these two types is how the light rays form the image. If the actual light rays meet, we get a real image. If only the extensions of light rays meet, we get a virtual image. Real images. When converging rays strike the mirror, a real image is formed. Converging rays are rays that move toward each other. When these rays actually meet at a point after reflection, a real image is created. It has the following properties. First, it is formed by the actual intersection of the reflected rays. This means that the reflected rays themselves meet at the image location. The image is not just an illusion created by our eyes, the light is actually reaching that point. And second, that it is located in front of the mirror. Um, for a real image, the image forms on the same side of the mirror as the object. And third, it can be projected onto a screen. And because real images are formed by um, actual light rays meeting, we can place a screen at that location and capture the image. For example, the image produced by a projector on a classroom screen or a cinema is a real image. That is what we call a real image. And fourth, it is generally inverted relative to the object. This means that the image appeared upside down compared to the original object. And in this diagram, the object is placed in front of the mirror. The reflected rays meet at a point, creating the real image. And notice that the image is inverted and formed in front of the mirror. Virtual images. When divergent rays strike the mirror, a virtual image is formed. And divergent rays are rays that spread away from each other, and since these rays do not actually meet, we extend them backward to find where they appear to come from. And this creates a virtual image. It has the following properties. First, it is formed by the intersection of extensions of the reflected rays. And the reflected rays do not actually meet behind the mirror. However, if we extend their paths backward, they appear to come from a point behind the mirror, as you can see in here. And second, it is located behind the mirror. Well, the image appears behind the mirror, but there's no actual light in there. And third, it cannot be projected onto a screen. Since the light rays do not actually meet at the image location, placing a screen there will not capture the image. And fourth, it generally is upright relative to the object. And what this means is that the image has the same direction as the original object and not upside down. And in this diagram, the reflected rays are spreading apart. And when we extend these rays backward, they meet behind the mirror, creating a virtual image. And a common example of a virtual image is the image that we see in everyday mirrors, like a bathroom mirror. Mirrors. Let's get into what mirrors are. Well, a mirror is a smooth, polished surface that reflects light. And the reason mirrors can form clear images is because their surfaces are very smooth. And when light hits a rough surface, it scatters in many directions, as we studied in the previous lesson. But a mirror reflects light in an organized way. Mirrors are mainly classified into two types: plane mirrors and inclined mirrors. Plane mirror. A plane mirror has a flat reflecting surface. The mirrors we commonly use at home are examples of plane mirrors, and a plane mirror forms a virtual image behind the mirror. And this happens because the reflected rays spread out and our eyes trace them backward, making that it makes them appear as if the light came from behind the mirror. And the image properties are um, the following. First, it is virtual and upright. The image cannot be projected onto a screen and it appears standing in the same direction as the object. And second is that it has the same size as the object. And three, object distance equals image distance. And what this means is that the distance from the object to the mirror is exactly equal to the distance from the image to the mirror. And if an object is 2 meters in front of the mirror, its image appears 2 meters behind the mirror. And fourth, that is, it is laterally inverted, and this means that the left side and the right side are switched. For example, when you raise, like when you're in front of a plane mirror, when you raise your right hand in front of the mirror, the image appears to raise its left hand. Inclined mirrors. Inclined mirrors are formed by placing two plane mirrors at an angle theta to each other. When two mirrors are placed together, each mirror reflects the object and also reflects the image created by the other mirror. And because of repeated reflections, multiple images are formed. And a common example is two mirrors placed at an angle in a science experiment, for example, where you can see many repeated images. Let's get into number of images. The number of images formed depends on the angle between the mirrors. These are the formulas for it. The first formula, n equals 360 degrees to theta negative 1, where n represents the number of images, theta represents the angle between the mirrors. And for example, if I want to give an example to you, is that if the angle between two mirrors decrease, the number of reflections increases, so more images are formed. And the smaller the angle between the mirrors, the greater the numbers of images, and this is something that you should keep in mind. And this formula can also be rearranged to find the angle. For example, if you have been given the number for the images, the n, and not the theta, the angle between the two mirrors, you can use the second formula, which is theta equals 360 degrees to n plus 1. And there's a little note in here that this formula is valid when 360 divided by theta gives a whole number. And here we are done with today's lesson. Hope you enjoyed watching this.